All right, so let's go and then see the architecture. All right, so this is how it looks like, right? This is how sequence to sequence models look like. So we have what is called encoder and then decoder. Okay, encoder and then the decoder. So you encode something and then it is going to decode it. Okay, so for instance, we encoded some words over here, right? So I can maybe encode, right, how is your day. Okay, so that is the text that I'm encoding or I'm forming over here. Then it's going to try to understand it or try to decode it to another language. Okay, so encoder, decoder, encoder, decoder. Okay, so that's it. All right, that's the two parts that it has. So for instance here I've just represented the text as in A, B, C, right? And I mean, reality is gonna be more than that. For instance, how is having 3 letters, is having 1, 2 letters, right? Year is having 1, 2, 3, 4, 5, right? I mean 4 letters, right? And then day is having 3 letters. So I've just represented with A, B, C. So maybe it could be how are you, something like that. Okay. Now, over here, if you remember in the LSTM, right, architecture, right, we have when we put in the input, you're supposed to have output, and then we transfer it to the next, right, and then we get output, then we transfer it to the next, then we get output, right. But over here, it's not like that. Okay, here we only get the output at the end of the string, or EOS, end of the string. That's where when we get the output. Okay, then once we get the output, and then we push it to the decoder part. Okay, so for instance here we will not say how, and then your machine will just translate only how. If you want how is your day. Okay, it will translate all of them. How is your day? It's not that it's going to translate how on its own, then it's on its own, your on its own, day on its own. It has to wait to get the context. Okay, the context of whatever that you are saying, so that it will be able to give you the right translation. Okay, if you remember when we go all the way back here, right, when we're given this example of translating English to Hindi, okay, this particular example, okay, we say that I am going. If you're going to translate it here, right, and if you want to do it I mean word to word, then it's gonna give you a different translation altogether. Okay, so you need to get the entire context so that you can reorder it correctly. So that's what I mean this one is going to do. So that's why you don't have output as it is. Okay, because this one, as you put in the input, you have the output to transfer to the next, you get the out, you get another input, right, you get the output to transfer to the next, you get the output, something like that. But this, in this case, it's not like that. Okay, sequential models will wait till it has the entire context before it gives you the, I mean, it has already encoded, you finish encoding everything before you get the output over here. Okay, and then it will now decode it. So here you're going to have the input, right, the input of A to pass through the LSTM. Okay, and this one, I mean, this architecture can change. It's not that it's going to be always LSTM. It could be RNN itself, or LSTM, or GRU. Okay, so I mean it can be any of them, right, but mostly we use LSTM for these kind of tasks. Okay, so you're going to have your, I mean, your input over here. Okay, and here you're traveling through time. Okay, remember you're traveling through time. So maybe you can have time t1, you can have time t1, time t2, time t3, right, and then finally you'll reach at the end of your string. Okay, at the end of your string is your final output. So if you have A, right, which you pass through over here, right, and then here you have your B, which will also pass through, and then you have your C, which will pass through, and then you get your final output when you reach the end of your string. Okay, end of your string is just nothing but end of your sentence. All right, and then here it's going to now the W here, which is nothing but your output, right? So this one is going to be some sort of an output vector. Okay, some output vector over there. And it's going to be now fed to this decoder to decode whatever that you encoded over here. Okay, and then you get your output. So let's say this is the output that you need to have, right? X, Y, Z. So you're supposed to have an input of A, B, C, and then you have your output of X, Y, Z. So you put in this W, which has been encoded from here, you get your X, and then you feed the X, right, to the next LSTM layer, and then you get the Y, right, and then you put the Y in, right, and then you get the Z. Okay, and then finally you put the Z over here, and then you're going to have your end of string, which will give you the X, Y, right, X, Y, Z. Okay, which will give you the X, Y, Z finally. All right, so that's basically what this architecture looks like. All right, okay, So this is another way to look at it. So for instance, if you want to translate language from say French, right, French to say English, okay, French to English. So the little bird took its flight. That is the French version of that. Okay, so in the encoder, this is what you are encoding in. Okay, this is what you're encoding in. All right, this is what you're encoding in. And then once you reach the end, you're gonna have your vector. Okay, that is the context vector, right? After you've gotten the context of whatever that you want to say. Okay, because if someone writes I am dancing, okay, I am dancing, and then someone writes dancing is my hobby. Okay, in this case here we have dancing and we have dancing, but the context is different. Okay, I am dancing, this one becomes a verb, but dancing is my hobby, this dancing becomes a noun. Okay, so we have to get the entire context. Okay, so that we have the context vector, and that is the context vector that you're going to give to this one. Okay, so you have your start of string and then your end of string over here. Okay, so you put in there, right, and then you have little, you put in little, then you have the bird, you put in bird, then you have took, you put in took, then you have eight, you put in eight, you have flight, you put in flight, and then you have the entire the entire sequence of words. Okay, all right, so it's not that this one here is supposed to have the same length as this one. Okay, I mean, you can have short length over here and then long length. Okay, so I mean, you can see example over here in Google Translate. Right, the length is not supposed to be the same. Here we have 1 2 3 4. Here we have 1 2 3 4. But it's also possible that here you can have maybe, let's say let me try something, going home. Okay, so you see that here I have the length here is 2 words, but the length here is 3 words. Okay, so I mean the architecture here could be 2, right? We can have 2 LSTMs over there, right? And then here we have 3 LSTM for the decoder part. Okay, so the encoder can have 2 and the decoder can have 3. Okay, so something like that. All right, so that's how we use the encoder and the decoder for the translation. Okay, and then this is also an example over here where we have the LSTM architecture over here. Okay, and you can see over here we have language. Here we are not translating. Okay, we have language that we want to if you, for instance, if you have a Gmail account and then someone sent you an email, right, as soon as you open the email, you see that it is suggesting an auto response, okay, or auto reply to that email. So for instance, if someone has sent you an incoming email saying that are you free tomorrow, and then you see that Google is suggesting there that yes, what's up, okay, something like that, or maybe yes, I am free, or maybe it will give you some sort of a suggestion. Okay, if you go to LinkedIn and then you try to reply to someone has sent you a message and you try to reply. Let me go here and show you an example. So here is LinkedIn. All right, so let me show you an example. So I'm just gonna open just a random message here. Now you see that here you can see that there's a suggestion over here. So you see that as soon as you open the message, it's trying to give you a suggestion of what to say next. Okay, what to say next. So that is sequence to sequence. Okay, that's some kind of example that I am trying to tell you. So that's how these things work, right? So this is an incoming. Here we are not predicting like here that we want to translate from one language to another language, right? Here we want to, based on what has come, right? What is the probability that what has come, the reply will be something like that. Okay, so that will make it easier for the user to reply to the message. Okay, and by doing so, they are engaging their customers to interact on their app. Okay, to make it easier for them. All right, so that's a sequence to sequence for you, right? So basically, it's gonna be something like this. Okay, what is the probability of predicting say yes, what's up? Okay, so what is the probability of predicting say yes, comma what's, okay, comma up, right? Given that you have you, comma, and then free, and then tomorrow. Okay, what is the probability of this one? Right, a comma, a question mark. Okay, so what is the probability of predicting something like this? Okay, giving something like this. Don't forget that the LSTM is just gonna give you a probability at the end of the day. Okay, So what is the probability of predicting these words given that? Okay, in the same way over here, right? What is the probability of you predicting okay, or the person typing okay, or what's the location or hi, giving this kind of main message? Okay, giving this kind of message. All right, so something like that. Okay, that's how this sequence to sequence model works, right? We're going to see some implementation of that. There's a problem with this one too as well, right? So mainly what is happening in the industry is that people try to make improvements and adjustment to whatever has been developed. Okay, so if something is developed today, okay, if something is developed today, tomorrow someone wants to come and then improve it. Okay, so if you learn sequence to sequence models today, right, it's possible that tomorrow some other model will come because they're going to improve upon it. Okay, for instance, this one has a problem with accuracy when the sentences are very long. Okay, it has a problem with getting the accurate translations or getting the accurate results. Okay, for instance, it's this one, right? Let me take this is just a short sentence over here, but if the sentence is very, very long, it's going to be finding it difficult to predict the exact reply that is supposed to come here. Okay, so it's possible that this one is using, what they are using here is an improved version of the sequence to sequence. Okay, so we have another one that we call attention. Okay, we have another one that we call attention, right, using transformers. Okay, we have another one called attention using transformers, which is a modification of the sequence to sequence, right? And it's possible that by the time that you're watching this video, another one might have come, right, which is improving the attention model. Okay, so that's why I said keep on reading the research papers, because all these things are in the research papers. Okay, all these things are in the research papers. I'll give you links to these models as well. Okay, let me introduce you to this attention as well, so that you get familiar with it. All right, and then we see some implementation of that.